An IQ test is designed so that the mean is 100 and the standard deviation is 20 for the population of normal adults. Find the sample size necessary to estimate the mean IQ score of statistics students such that it can be said with 99% confidence that the sample mean is within 8 IQ points of the true mean. Within 8 IQ points means then that the margin of error needs to be 8. We are no more than 8 units from the true mean. Determine the required sample size using technology. Okay, well, so we're going to determine the sample size. So this is going to require that we use the formula n equals z sigma over E, and then that whole quantity squared. Now we know what sigma and E are. What we need is Z. And we're going to find Z using technology, using StatCrunch. So we'll go to StatCrunch. And we're going to use the normal calculator. So we'll go to Stat, Calculator, Normal. We want a 99% confidence interval. So we're going to leave the mean at 0, the standard deviation at 1, and then over here in this last box here, we're going to type 0.005. And this is going to give us a value of minus 2.576 if we round to 3 decimal places. Now, why did we do 0.005? Well, if we have a 99% confidence interval, then what we are looking for is that Z value so that we would have in between these Z values 99% of the distribution in between these values. So this shaded, this area that I'm shading here would represent 99% of the distribution. Okay, so if that's the case, then we would need 0.005 here. That's why we typed in this 0.005. We would need that to the left of this value here, and then we could change this to greater than, make this 0.005, and we wind up with this upper value up here, which again is going to be 2.576 because the normal distribution is symmetric. So we have minus 2.576 to the left here and positive 2.576 to the right. So now using that formula then, we have n equals z, that's going to be 2.576, times sigma. Sigma we're told is 20, and then divided by E, the margin of error, and we're told that's to be 8, and then we're going to have to square that whole quantity. And that gives us a value of 41.4736, which I'll call 41.5 for now, just round it to one decimal place. Now, here's the thing. You can't sample a part of a person or an object. So in other words, you can't have a decimal place for n here. It has to be a counting number. So what we need to do is always round up when we are calculating sample sizes. When we're estimating an adequate sample size, we always round up. And that is so that we don't compromise precision or confidence. So this sample size then, the adequate sample size for doing this is going to be 42.